Hi everyone, in this video we're going to look at increasing and decreasing intervals for functions. For this one, like many other function videos, it'll really help to graph the functions first so we can visually see what's going on. So I've got here for each one of these functions a graph off to the side here so we can see what the increasing and decreasing intervals are going to be. So looking at the first one, g of x equals negative parentheses x plus 4 quantity squared. This is going to be a quadratic, which you can see over here, the upside down u. The negative, of course, makes it upside down. You'll see here the point right there is at negative 4, 0. That's pretty important to know what that point is. When we're doing increasing and decreasing, we're always going to do x intervals. We need to always do x intervals because these are all going to be functions. We're doing function features after all. And functions have distinct values of y for each x. So if I say x equals 4, there's only one y value that goes with that x of 4. Whereas going backwards, if I say, for example, for this graph, a y of negative 10, there's more than one x that has a y of negative 10. So we couldn't use y intervals. It wouldn't make any sense because if I said, for example, negative infinity to 0 for y's, well, that's increasing and it's decreasing. So it doesn't make any sense. Whereas x intervals, there's only one way we could write it that would be clear enough to say increasing and decreasing. So always make sure you do x intervals for increasing and decreasing. So for this one here, we can see the vertex is up top, and we always read a graph like you read a book from left to right. So we're going to start over here, and if you put a little person here, you can kind of watch this person move. So this person on the left starts and goes like this, and then it goes like this. And that kind of can make you think about what the function is doing. So the person is increasing, they're going up, and then they're going down. So the function is increasing up until this point, and then it's decreasing after that point. So we're just going to need to say that those intervals using interval or inequality notation. So this person here can't go forever infinitely down. There's not enough space ever in the universe to show that. So we have to just remember that this line here, this part of the quadratic would keep going forever, as would this side. So don't forget about those arrows that would be on there. So this person starts at negative infinity, and then he or she travels all the way up to this point and then starts decreasing after that. So we've got to just say that again using notations here. So from negative, so we're going to do increasing first since the person starts increasing and then decreases after that. So increasing interval would be from negative infinity to negative 4. And this person decreases after negative 4. So negative 4 to infinity. Those would be interval notation, or you could say negative infinity is less than x, which is less than negative 4, or negative 4 is less than x, which is less than infinity for inequality notation. So this is interval, this is inequality. Depending on the question, it might ask you for a certain kind of notation, so there's both of them. So you might be wondering, why did I use open brackets here and not include the negative 4 in either of these? Well, the problem is, you can't include it in both. You can't say it's increasing and it's decreasing at negative 4. So to be safe, we typically don't include it in either. You could technically put it in one of them or the other, but again, we don't want it in both because it can't be increasing and decreasing at the same place. And typically, you don't even use it at all because you can't increase at one single point. If I say, how is this person increasing or decreasing at this dot? Well, that's not possible. There has to be some kind of distance to increase or decrease over. So we typically just, again, to be safe, don't include the point where it kind of turns because it's not necessary and it could make mistakes if you include it in both. So that's how we would do increasing and decreasing for this example. For the next example here, very similar. I'm going to calculate my little person down. So this person starts on the left side of the graph and then reads this or travels this like you would read a book. So travels this way and then that way. So this person is always going up. It's a very slight increase, but we're always increasing. There is no decreasing here. So we can just say increasing forever. You could say all real numbers. You could say negative infinity to infinity. But there is no point where this turns because it's always increasing. Even though there's a little bit of a, looks like it's a little bit of a turn here. It's not actually changing from increasing to decreasing. It's always increasing upward. So either way you want to write it is fine, unless the question asks a certain way to do it. This would be interval notation, and this would be inequality notation. Again, this person would be always increasing, so this graph is always increasing. And that's how we do intervals for increasing and decreasing for functions.